So we have a rational function here, and remember that the first step that we do with a rational function is we go ahead and factor the numerator and the denominator of the function. Factoring the numerator, I end up with 3x, and I'm going to have a negative 2 here, I'm going to have a 1 here, and a plus. Okay, so x minus 2 and 3x plus 1. Double checking to make sure that I'm factored correctly. In the denominator, I have the difference of two squares, so I have x plus 3 and x minus 3. Next, I'm going to look and see if I have vertical asymptotes and if I have any common factors. So, common factors, there are no common factors between the numerator and the denominator, so no. Therefore, there's no wholes. So you need to have common factors to have wholes. No wholes. So then we're going to look at our denominator, and we're going to be looking for our vertical asymptotes. So our vertical asymptote is going to be when the denominator is equal to 0. Solving these equations, we end up with x plus 3 has to be either 0 or x minus 3 has to be equal to 0. So x has to equal negative 3 or x has to equal 3. And that's the equations of my vertical asymptotes. So x equals negative 3 and x equals 3. And those are my vertical asymptotes. Next, I'm going to look for my x-intercepts. So my x-intercepts are when my numerator is equal to 0. So I'm going to take this numerator, 3x plus 1, and x minus 2, and I'm going to set it equal to 0. And then I'm going to take each one of those factors and solve for x. And when I do that, I end up with x is equal to negative 1/3 or x is equal to 2. So my x-intercepts are going to have coordinates negative 1/3, 0, or 2, 0. So those are my x-intercepts. Those are the zeros of my function. Next are the y-intercepts. And the y-intercepts are found when we take the original function and put in a 0 wherever we have an x. So to find the y-intercepts, I'm going to put in 0 for x. And I end up with 3 times 0 squared minus 5 times 0 minus 2. 0 squared minus 9. So notice what happens when you put in 0 wherever there is an x in your original function. All those terms cancel out. They disappear. And we're left over with f of 0 is equal to negative 2/9. Negative 2 over negative 9, which equals 2/9. So then my y-intercept is going to have coordinates 0, 2/9. So that's an important point also. Next, we're going to look for our horizontal asymptote or our slant asymptote. So I'm going to go back to the original function. I'm going to be looking at it, and I'm looking at the degree of the numerator and the degree of the denominator. So we have a second degree in the numerator and a second degree in the denominator. So the degrees are equal. That's n is equal to m, equal degrees, equal degreed polynomials. So when we're looking at equal degrees of the polynomials, then we're going to just look at the coefficients of each of the highest terms in those polynomials. So my HA is going to be in the form of y equals the coefficient of x squared in the numerator divided by the coefficient of x squared in the denominator, simplifying y equals 3. And that's my horizontal asymptote. Now I'm ready to graph, and I'm going to start by using a sign graph. And I'm going to end up with 4 different factors, so I want to make sure to leave myself some room to be able to put in all 4 factors. I need to write down where my 0 is at, and I'm going to go ahead and put in my vertical asymptotes. So my vertical asymptotes are at negative 3 and 3, so I'm going to go ahead and put in vertical asymptotes at 3 and negative 3. I'm also going to put in my zeros, and remember my zeros are my x-intercepts. So I have a 0 at 2, 0. And I have another one at negative 1/3, 0. So right there. And remember that I'm going to use a little squiggly line to break my graph off up wherever I have a 0. Then over on the left side, I'm going to write down each one of my factors in both the numerator and the denominator. So we have 3x plus 1 in the numerator, x minus 2 in the denominator, x plus 3, and x minus 3. And then I'm going to go ahead and do my sign chart for each one of these intervals. I'm going to look for a number that's to the left of negative 3, so that's going to make this negative, 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 negative. Overall, the entire function is going to be positive. So I multiply negative times a negative times a negative times a negative. You could use division too. It doesn't really matter. We actually are multiplying these two together in the numerator, and we're multiplying these two in the denominator. So in essence, we have a positive divided by a positive. But I really just count the number of negatives that I have. If it's an even number of negatives, it ends up being positive. If it's an odd number of negatives, then I end up with a negative. Okay, in the next interval, I need to pick a number between negative 1/3 and negative 3. So I'm just going to pick negative 2. And I end up with a negative, negative, positive, negative. So here I have 1, 2, 3 negatives, which is an odd number of negatives. So that means that overall my function is going to be negative. Then a number between negative 1/3 and 2, I'm just going to 0. So this becomes positive, negative, positive, negative. I have an even number of negatives. That means that my function overall is going to be positive. A number between 2 and 3, I'm going to pick 2.5. And we have positive, 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 negative. I have one negative. That's an odd number of negatives. So overall my function is going to be negative. And then to the right of 3, which gives me positives all the way through. So overall my function then is positive. I'm going to go ahead and draw my graph using my sign graph now and the other information that I was given, my horizontal asymptote and my y-intercept. So I've used everything else. I've used my vertical asymptotes. I've used my zeros. I've plotted those. Now I need to do things in the y direction. So I have my graph started already. Notice that I put in my vertical asymptotes here and here. And I'm going to go ahead and put in my zeros. I have a 0 at 2, 0, and at negative 1/3, 0. I have a y-intercept at 0, 2/9, which is going to be about right there. And then I have a horizontal asymptote, so I need to put that in there, and it's at y is equal to 3. Now one thing that we didn't calculate out is, does our graph cross the horizontal asymptote? So when y is equal to 3, is my function give me an x value? So I'm going to go ahead over here and figure this out. So I'm going to take the value of my horizontal asymptote, 3, and I'm going to set it equal to my function, which is 3x squared minus 5x minus 2 all over x squared minus 9. I'm going to multiply both sides of the equation by x squared minus 9. When I do that, I end up with 3x squared minus 27. On the right side, these guys cancel out, and I'm left over with 3x squared minus 5x minus 2. When I subtract 3x squared from both sides of the equation, they cancel out. So then I'm left over with negative 27 equals negative 5x minus 2. Adding 2 to both sides, negative 25 equals negative 5x. And then dividing by negative 5. So yes, my graph does cross the horizontal asymptote at the point x equal to 5, y equal to 3. So it crosses the HA at 5, 3. So I need to include that point on my graph also. So 3, 4, 5, and then the horizontal asymptote. So it's right there that I'm going to be crossing. Okay, now I'm going to go ahead and use my sign graph. So to the left of negative 3, I'm going to be positive. The entire graph has to be positive. Remember that we have to approach our asymptotes. We're not going to go over them or past them. So I have a choice. I can either go down this way, where I approach both of my asymptotes, or I can approach both of them this way. If I do it this way, I end up in a negative value. Remember, this is my x-axis right here, and here's my y-axis. So if I start up in the positive side, for me to approach the vertical asymptote, I'm going to have to go down negative, and I don't want to do that. I want to stay positive the entire way. So I need to be above the horizontal and to the left of the vertical asymptote. So here is my graph on the left side. Then between -3 and 1/3, I'm going to be negative. So that means I'm going to be below the x-axis. Here's my x-axis. I'm going to be below, and then at -1/3, I'm going to touch it. So there we are, below. Then between -1/3 and 2, between these two, I am positive. I know I have to go through the y-intercept, and then I have to go through the point 20. So I know I'm going to come around this way. And then between 2 and 3, I'm negative. That means I'm going to be below the x-axis, and I'm going to be approaching my asymptote that way. To the right of my vertical asymptote of x equal to 3, I'm positive. So that means, again, that I need to be up in this region. If I'm down in here, then I'm going to be negative at some point, and I can't be negative. But we've got this guy that's kind of worrisome. So it would, you might think that you could come up and go across this way, but again, I can't be negative. I have to be positive in this entire area. So what's going to happen is the graph is going to come down. It's going to cross the horizontal asymptote. It's going to go below the horizontal asymptote, and then it's going to come back up and approach it from the bottom side instead of from the top side. And that's what this graph is going to look like.